Hello students, welcome to this next session on industrial metallurgy. We were discussing the basic terms that are used in the field of physical metallurgy or industrial metallurgy. This is session 5 and would be devoted to another very basic term called degrees of freedom. Please don't mix this degrees of freedom with the term that you have been studying in mechanics of machines or dynamics of machines. This pertains to materials engineering, industrial metallurgy. So let's define what is meant by degrees of freedom. You see, degrees of freedom of a material system under some given conditions of pressure, temperature, etc. is the total number of variables or parameters which can be changed independently, means without looking at the other variables, without bringing about any change in the existing phases, which has been written here as without bringing out the disappearance of an already existing phase or the formation of a new phase. In other words, suppose you have a materials system present under some conditions of pressure, temperature, composition. Under these given conditions, this is possessing some number of phases and some type of phases in it. Now, if these means under these given conditions, now how many number of variables are there which you can change independently at your discretion, means you can disturb them from their existing value. For example, pressure is at 1 bar and you say that, sir, I can make it 1.1 bar at my discretion and still the phases would be the same as were existing in the system. So what are the total number of variables for an existing material system under the existing conditions which would not bring about any appearance of a new phase or will not lead to disappearance of an already existing phase, which I said will not bring about any change in the phases. Though that number, total number of variables, is the degrees of freedom for the system. For example, you say, sir, there is only one variable that can be changed independently and its change will not lead to any phase changes in the system. This system has got 1 degrees of freedom. But if you say, sir, under these given conditions, for this material system, I can change 4 parameters and still the phases would not change, nor in number, nor in type, this system has got 4 degrees of freedom, right? So the parameters or the variables which can act as degrees of freedom can be even internal variables like composition, or can be external variables like temperature, pressure, surface tension forces, gravitational forces, magnetic forces, electric forces, anything which you can change and which can bring about the any variable which has the potential of bringing about a change in the phases of a material system can act as a variable over here. So to further elaborate this term, what we have done is we have taken the example of a one component system, and in that one component system, for example, so this is the equilibrium diagram of that one component system, which is showing that in this entire region there is only one phase present in the system, the gas phase. And in this region, again, this is a single phase region where there is only one phase, the liquid phase. And this is again a single phase region where there is only one phase, the solid phase. And these yellow lines, these are called two phase boundaries or two phase equilibrium lines. Means if the system was at a pressure and temperature given by this cursor, I brought the cursor on the yellow line, then the system has got two phases in it, solid as well as liquid. Similarly, if the temperature and pressure of the system were defined by this red dot cursor point, then the system again has got two phases in it, liquid from the above and gas phase from the below. And similarly here again the system has got two phases in it, solid as well as gas, and this is a single triple point where the system will have all three phases coexisting in it. So for an example, now if I am taking that, if this single component system at any point in time is defined by a pressure and temperature so that it has got one phase in it, how many degrees of freedom are available with the material system? So for example, I have considered that my system was defined by point A and it was at pressure PA and temperature TA. And now see, this is a single phase region, gas phase. So now I'm trying to see that, see, and here what you can see is this is a single component system, so composition cannot act as a variable. That is 100% whatsoever is the composition of the system. And there are two variables which are being shown, pressure and temperature. So composition cannot act as a degree of freedom because it's not a variable. Pressure and temperature can act as a variable. So I have to see whether pressure or temperature or both or none of them is a degree of freedom. So we are talking about case one, when the system is present in any of these single phase regions, here or here or here. So for this illustration, I have considered that the single phase region in which the material system is present is the gas phase region. Now students, you have to see that if you disturb the value of temperature from this existing value, it is at Ta. See, you can go to this, you can increase the value of Ta dash. You don't have to bother about the value of pressure. You could have changed the value of T to T, like I have changed here from A to A dash. So I've changed the value of temperature from Ta to Ta dash. And I'm not bothering about the value of pressure. I could have changed it. I could have changed the value of pressure and I would have come over here. So if I'm changing the value of temperature from Ta to Ta dash, this is my own discretion. I'm just trying to see whether I can disturb the existing value of temperature or not. And so you see, I have disturbed it and I have achieved a value Ta dash, and I have achieved it in such a manner that the existing phase type and number have not changed. The system was earlier in a single phase region gas, it is still in a single phase region gas. See, some students will start saying, sir, if I change the value of temperature to this an extent, the type of phase would change. The question is not that whether you can change the value of temperature to any an extent. The question is whether you can disturb the value of temperature from the existing value. And yes, you can see that you can disturb the value of temperature to a newer value and still you are at. Similarly, I could have done with the pressure value. So in this particular case, when a system is in a single phase region, both pressure and temperature can be changed independently and still the system will have no changes in its phase. So both are degrees of freedom. So here I have written that degrees of freedom are 2. Now let us see that rather than one phase, if the system was existing over here or here, when it had got two phases in it, what would be the difference? Now if the system is on a two-phase line, see, what does the degree of freedom definition says? The degrees of freedom definition says that you should be able to change the variables independently and still the phase type and the number should remain unchanged. So if now my material system is being defined by this pressure and this temperature by point B, it has got two phases in it, gas phase and solid phase. So when I change pressure and temperature, I have to see that this two-phase region should not be lost. What does that mean, students? In other words, I should not leave this line. No sooner I leave this line, I will not have exactly this and this phase in my material system. So if the system is here, what I'm doing in the first case, say I change the temperature value from TB to TB dash. I change the value from TB to TB dash, means I come from point B to point B dash. I could have changed the value of TB to TB dash till here, say, then I would have come over here. The point is that you are changing the value of temperature independently at your as your discretion. But no sooner you change the value of temperature by an extent, depending upon what change you have brought in the value of temperature, the pressure value also needs to be changed accordingly. And you realize that if I change the value of temperature by this an extent, so that still the temperature composition points remains on this line, I will have to change the pressure by this amount. So temperature you have changed independently, but then pressure change has become dependent on temperature. So there is only one variable which you have been able to change independently, and that variable is temperature. So you have used temperature as a degree of freedom. You could have done the reverse of it. You could have changed the value of pressure by your own self, but no sooner you would have changed the pressure by your own discretion, you ought to change the value of temperature, and that change in temperature would have become dependent on the change in pressure that was brought about. So when a single component system has got two phases in it, it has got only 1 degree of freedom. That degree of freedom can be exercised either in terms of temperature or can be exercised in terms of pressure. Now let's come to the third and the same discussion that I have done for this two-phase region, the same would apply to the other two-phase regions also. Now let's come to the third case. Single component system we have taken, and now let us assume that it has got 3 phases in it. We are wishing to see how many degrees of freedom. You see this triple point, 3 phases coexisting, comes at a unique value of temperature and pressure. If you disturb either pressure or temperature, this point, this unique point would be lost. So you cannot change pressure, you cannot change temperature. There are 0 degrees of freedom in the system, in a single component system, when it has got 3 phases coexisting in it. So the summary is that when a single component system, one component system, has got 2 degrees of freedom when it is in a single phase region, it has got 1 degrees of freedom when it is a 2 phase region, and it has got 0 degrees of freedom when it is in a 3 phase region. Students, thank you so much for watching. Bye.